This is matter. Matter is any physical substance that occupies space. There are many states of matter. We have liquid, solid, gas, plasma, Bose-Einstein condensate, quark-gluon plasma, neutronium, nuclear matter, time crystals. These matter types are differentiated based on their chemical bonds. That's the bonds between molecules and atoms. These bonds are stronger in solids. And then when we heat it up, we have liquids. And when we further heat them up, we have gas. Matter in the solid state maintains a fixed volume and shape. Matter in liquid state maintains a fixed volume but has a variable shape where its constituents move freely. Matter in a gaseous state has both variable volume and shape. Its particles are neither close together or fixed in place. Phase transitions do occur to these states of matter, where a substance in one state could transform into another state. The stages the constituent particles go through to enter the new phase is called the mesophase stages. Solid melt into liquid, liquid freeze into solid, gas undergoing deposition to become solid, gas condensing to become liquid, solid subliming to become gas, and so on. A change in temperature is what we experience for the four basic states of matter, but it's a bit more complicated when we reach the states of the small. We can use a phase diagram to explain what states of matter really are. At temperatures and pressures above the critical point, we have a supercritical fluid. A single water molecule doesn't have a temperature, but it has a velocity. The average motion of all the molecules is its temperature. When we look at the equation of state, pressure should be proportional to temperature and inversely proportional to volume. Thermodynamics in general is the branch of physics that studies relationships between the statistical properties of different states of matter. But a state of matter is determined by something more than thermodynamics. Example, quantities such as wetness of water. Solids, for example, have infinite viscosity. Liquids could be viscous, but a superfluid, which is kind of like a liquid, has an almost non-existent viscosity. Superfluids are liquids formed at temperatures close to absolute zero and they have near zero viscosity. States of matter could be identified with interactions between components under conditions. If we increase the temperature of plasma, we have a quark-gluon plasma at the Hagedorn temperature. A quark-gluon plasma is liquid, and that is why some scientists call it quark-gluon plasma soup. It could be frozen and we could have nucleons. Quark-gluon plasma and fermionic condensate are examples of forms of matter that are not composed of molecules but are made up of different forces rather. Bose-Einstein condensate, as discovered by Albert Einstein and Satyendra Nath Bose, is matter in a single quantum state and can be described with a single uniform wave function. It is colder than a solid and it could be formed when all its constituent atoms are in the same quantum level close to absolute zero temperatures. Glass is also another state of matter, but unlike solids, it's non-crystalline, that's amorphous. It's made up of different materials from ionic melts to aqueous solutions to molecular liquids to polymers, etc. Superconductors are also materials with zero electrical resistivity, therefore, they are perfect conductors. They could be described as a different state because they exist at extremely low temperatures. In neutronium, all quantum states are occupied, leading to superconductivity and superfluidity. At absolute zero, everything else freezes, but time crystals move. Fun, right? Interesting. These other conditions being time in time crystals, quantum state occupation for neutronium, state of mobility and immobility of the constituent of particles or matter like the gluon plasma, then we have viscosity, could be factors that describe the state of matter of a substance. Neutronium are believed to exist in the core of neutron stars. Other notable states of matter include degenerate matter, quark matter, color glass condensate, very high energy states, super solid, string net liquid, super glass, chain melted, quantum Hall state, photonic matter, amongst others. These are matter, and this is what we have for you for the states of matter. Thank you very much. Until next time, this is Einstein in a Flash. Goodbye.